Okay. Alright, so the next thing on the bench here we have is a Kenwood KR7400 stereo receiver. These were really nice, 63 watts per channel, very clean, very good low end, that nice 70s sound. And other than having a couple of the capacitors replaced, nothing's been done on it. It plays right now, but not perfectly. The tuner needs aligned, I think, might need some work, and we may need to do a recap on it, I don't know, but I'm going to take it apart and go over it and see what we get. Okay, so for the most part, looks like some work. I think I may have done some work on this in the past. This has been sitting around on a shelf for a long time. Looks like the main amplifier has been recapped. I think we can see these look recapped. This is definitely aftermarket. I think I did replace those. Idle current on this is hard to adjust on the original pots because they're a one turn. Looks like I put a 10 or 15 turn pot in there to make it a little more adjustable. Does not look like anything was done to the tuner, so we may have to go over some of that. Looking at the power supply board, looking around here, I think that may have been recapped. You can see where the glue used to be, larger capacitors, the older ones, and these are looking like yep, 105 degree capacitors, new ones. So that's been replaced, these have been replaced. So yeah, looks like I've done some work on it already. So we're going to go over it the rest of the way, go over the tuner, check the tone control amp, check all the pots, make sure they're properly cleaned, lubricated, whatever. Clean up the faceplate, a little bit grungy, and see how it performs. And I do have a service manual for this, so I'll probably be opening that. We'll refer to some of that. Alright, let's dig in. Okay, here's where we are right now. We're going to test this out just to kind of see what the performance is like. I'll show you my crazy little setup here, and hopefully it'll make some sense. Let's see. So over here I have my signal generator, and I have both channels set to 1 kilohertz and an output of 150 millivolts RMS. Okay, and that's just going into the auxiliary input, and I'm just going by some of the specs for the amp that are specified there. The output of this amp should give us a good 63 watts RMS with no distortion or very low distortion. My dummy load rig here that I fashioned up a while back consists of two, if you look, 8 ohm 100 watt resistors. They're supposed to be non-inductive, mounted to actually an old heatsink off of a CPU from a computer, along with the fan on it. I got the fan blowing on the heatsink, and then it goes down to a couple of speaker wires, and then I go across it with my scope. And yes, this amp here shares a common ground. The only thing you have to watch when using an oscilloscope to look at two channels, if you have a some of these like Class D amplifiers, kind of like this, that use the isolated ground, if you hook your scope to both of them and hook the ground to both of them, you're going to tie the grounds together through the scope, and you may cause problems. So you just have to kind of watch that when you're working with this kind of a thing. So anyways, I didn't even set my scope up or anything yet. And basically what we're going to do, let's see here. Just kind of move this here, move this channel here. So I'm just on dual channel mode, and I'll turn on the output and turn my volume all the way down because I have no idea how this thing's going to work. I'm going to turn it on. And okay, looks good so far. And let's see if I turn the volume up, if we get any kind of an output. Well, it would help if we selected auxiliary. Okay, got bass and treble and mid all at mid-range, loudness off, muting. Okay, everything's good. So let's turn this up. And there we go. We are getting something here. So right there, let's align the phase. Okay, so as we can see, both channels are, boy, they're working dead over top of one another. I don't know if you all can see that. Right now I have it going up to plus and minus basically 20 volts peak to peak, and I don't have this turned up very high at all, about halfway. As you can see, it goes way up. Let's turn this down. Let's go up in scale. 10 volts per division. Let's take it till it clips. If it clips. It does not clip. So if I drive 150 millivolts RMS into it, even maxing out the volume, I won't even get clipping. Totally clean. That's pretty amazing. Look at that. Wow. Okay, so theoretically I have 10, 20, 30, so I have 60 volts peak to peak. Alright. My resistors are just getting barely warm, so my little heatsink thing's working. So let's do a little bit of math here. Turn this back on. Let me get the measurement. And we're going to do volts, which is the second one over here. Okay, and we were getting about 60 volts peak to peak. Alright, so let's do our little math formula. Get our calculator out. Get this turned down. And we do watts equals V squared. So it would be 60 times 60 divided by 8 ohms. That ain't right. Okay. Did a little bit of miscalculating from the scope. So we're going to use the meter here. The scope is actually showing you peak to peak, and the meter will actually read true RMS. I have a true RMS reading meter, and we're just going to use that rather than, because I forgot, when you're looking at the scope and you're looking at peak to peak voltage, you have to use the formula for that, which I did not do. So we're going to just read it off directly on the meter, and as you can see, we still have our normal waveform, and we're getting 20.64. So that's a little more like it. So if we take 20.64 times 20.64 equals, divided by 8 ohms, 53 watts. So with 150 millivolts input, which is kind of what they're speccing it out. I'm actually getting 53 watts. And I believe if we read the specifications on this amp, main amplifier 63 watts times 2. Let's see what it says. The input doesn't say with how much input you're getting, but basically, according to this, preamplifier input sensitivity 150 millivolts. Probably if we went up to 200 millivolts, give us a little more input. Wait a second here. Millivolts. Put those together, align the phase, and let's try it once again. I bet you we're going to see if we can get it, drive it into peaking. Yep, there it goes. Okay, right there's peak is, you can see we're kind of getting a little bit of clipping, and right there, no clipping right there. And it's 23.5 volts. So let's see what that looks like. I bet that's going to be more like it. 23.5 times 23.5 equals, divided by 8, 69 watts. So really this amp's putting out 69 watts, rated at 63. I think that's pretty darn good. So bottom line is, I think this thing's pretty well aligned. If I go way down on my volts here, I'm going to go down to about 20 millivolts per division on both of them, and you can see the one channel has a wee little bit of negative bias on it, talking maybe about 10 millivolts, perhaps negative 10 millivolts. The other channel does not. So that probably means we can just give that a little tweak to align it a little bit and bring it a little bit closer to idle current. But that 10 millivolts really is not going to hurt much of anything, truth be told. Let's see. But it's pretty good. Alright. We'll be back here in a minute. Okay. So, looking here at the schematic, little block diagram of the board, TP10 is on pin 7, TP11 is on pin 8, and on the other channel it's 18 and 17. So as you can see, I have my 2 meters there, and they're looking for an idle current of about 40 millivolts. Okay, and as you can see, I've been letting this sit for a little bit, and they're both hovering somewhere right around 40 millivolts. We're pretty close. Creeping up a little bit as it warms up, so we have to kind of let it settle, let it warm up a little bit, and give it another little adjustment, and bring it back in. And this is kind of a fussy thing. You just kind of do it over about 10-15 minutes just to make sure everything settles where it should. Okay. And again, this is not an exact science by any means, because originally this was a 1-turn pot that was really touchy, and by putting this 10-turn pot in here I can kind of split hairs a little bit. So really, if it hovers around 40 millivolts, it's good. So we can see that. And really all we're kind of doing is you're just putting a little idle current on the transistors to keep it from distorting at low volumes, but not so much idle current that it creates heat. So it's kind of a balance, and that's why they choose that type of idle current. Alright, so as you can see, everything looks good in the amplifier section. Very clean, very good output, 69 watts per channel. Both channels are pretty well balanced, low distortion. So really all we got to do now is kind of look at this tuner, and I think that's one of the reasons this thing ended up on the shelf, was that I think the tuner and to some degree the preamp had some issues, if I recall. It's been a long time and it needs looked at. So we're going to kind of scrutinize the preamp board as well as the tuner and make sure everything's good, and maybe this thing will be ready to go back to work for a while for us. Okay, I think I see one of our problems here, and I do think we need to look at the tone control and the preamp. If we look here, now earlier when we were looking at that nice symmetrical clean waveform, we were looking at 1 kilohertz. I've now moved us down to 40 cycles, 40 hertz on each channel. And watch what happens when I start to bring the volume up. As you can see, one channel is coming up just fine and going into clipping like it's supposed to, and look, the other one is way behind it, as you can see. And I believe that's probably either due to a bad capacitor that's starting to leak or go bad, or even maybe one of the little preamp transistors, but I'm looking more at a capacitor. So we're going to have to go through the tone control amp, which is really unpleasant because looking inside there, it's buried in there. Of course, they always are in these receivers. So we're going to have to go through, and honestly, probably the best thing to do is just a recap, so we don't even have to worry about it. I'm just going to go through and recap it. So that's where we are. So we'll be back once we get some things apart here and get into it. So this may not be so bad after all. Looking in here, we have our tone control board, and it's pretty readily accessible here. Looks like one capacitor may have been replaced at one point in time, and all the rest of these look original. That might be an original, but it definitely looks different than the others. But I'm starting to think that we have some issues on that one, and I might as well go change these little 4 caps here. And these other ones are always pretty good. I mean, you don't usually have to mess around with those. They're not the same as the wax and paper and the old tube amps and so forth. They're actually very reliable and actually very clean. The other thing I don't like is whenever I see tantalum capacitors. I know some people really like them, but I've seen a lot of weird things happen to those. So we're going to look into that as well. Okay, we'll get this apart and get it recapped, and then I guess we'll be back. Okay, so here we are. Got this caught up. Got it all recapped. I replaced all of these, and I replaced all of these in the phono preamp stage as well. What I found was a couple of those little tiny tantalum capacitors that were in there looked pretty leaky. Had a really high ESR, so I replaced all of these with really low ESR capacitors. The other thing I found out is all of these 6.8 microfarad capacitors were actually non-polarized capacitors, and the only ones I had some really good ones, but they were 10 microfarads. So I figured I kept the old 6.8s, and I can always put them back in, but I think the 10s are going to work fine in that circuit. And I put them in. We're going to try it, see what it sounds like, and hopefully this cleans up our problem with the non-linear low frequency on the 2 channels. So I guess the next step is to flip it around and turn it back on, see if everything's good, and if it is, then we'll move on to the tuner. Okay, we're set back up. If you look here, 40 cycles, 200 millivolts RMS driving in both channels. Got both channels aligned to one another. We're in dual trace mode, 10 volts per division, and so both signals are superimposed over one another, as you can see right there. And now as I increase the volume, they track together perfectly. Look at that. They even both clip at about the same point. So there it is. Perfect. So I think we're in good shape. That cleaned it right up. It's absolutely perfect now. The amp's running nice and cool, and everything seems to be as it should be, and I think we're going to be in good shape here. So the recap fixed it, and I think changing those caps on that phono section, I'm really kind of interested in seeing how that's going to be too. But there you have it. Now I think we're going to go on and check the tuner and see if it works, because I do believe it may have had a couple of issues with it as well. So we're going to look into that next. And maybe, I don't know yet, it's a little bit tricky, but we may even get into the SG165 and play around with the multiplex and see if we can get stereo to work as well. Alright, we'll be back here. Okay, so here's our setup. Getting ready to do some FM alignment, and as you can see, for FM they want you to put the sweep generator on TP1, 10.7 megahertz, non-station. Put your scope on TP2, which is right there, and they want you to go through a 100K resistor, which I probably should change that. And we're going to adjust L1 coil for maximum deflection. I'm using the SG165. I'm on the output 10.7 megahertz, and I got my markers. Doesn't really matter, but I do have sweep on. As you can hear, got that on. So we're just going to adjust that. My scope probe really doesn't affect the circuit much, so. But if we look, going down, going up, going down. So right about there's our peak. So we're done with that one. Okay, next. 98 megahertz. 400 hertz modulation, 75 kilohertz deviation, and we're going to adjust LA8, coil L8 for maximum deflection. Okay, alright, so let's set that up. So we want to go 98 megahertz. We want to put on our multiplex. We want 98 megahertz, and we're going to turn this up a little bit, go down, tune it into 98. Let's see if we can get it. And let's see where we're supposed to go into. Antenna through the dummy antenna. So let's disconnect our test lead, and give me a second and I'll put my little dummy antenna, which is nothing but 50 ohm resistor, 12.5 ohm resistor, and 150 ohm resistor across the antenna leads. So let me get that connected, I'll come right back. Okay, we're all connected, still on our same test point, and basically they just have us on test point 2, which is actually just the base of this transistor right here. And we're hooked up, as you can see, our little dummy antenna fixture, and we're on 98 megahertz roughly, RF, 400 hertz modulated. And if you listen, I'll turn that down a little bit. Okay, just till I get a little bit of fading out here. And we're going to now go ahead, and they want us to adjust number 8. So L8 is, there's 6, there's 10, there's 7, 11, L8 right here. Okay, so let me just listen a little bit and get in here with this little screwdriver, and let's look and see what we get. Not much of anything, huh? No deflection of the meters. Not getting a whole lot of difference. So let's look at this, make sure we're doing it right. Maximum deflection. Signal generator, 98 megahertz, tuned to 98. Output indicator TP2, LA8. Let's try that 100 ohm resistor and see if that makes any difference. I'll be right back. Okay, so here we are. I tried to adjust that L8. It has pretty much no adjustment at all. It doesn't really make any difference. So I guess in that instance we just move on. I'm just going to leave it where the mark was, and I'm going to leave it in its original position and not mess with it at all. Okay. Next. Turn that down. We don't need to listen to that. Discriminator, and this one always problems. So I always have problems getting an S-curve to show up on this, especially on this with these test points and so forth. I've tried all kinds of different things. I will just admit I have a very difficult time with the discriminators, especially on this type of equipment. So we'll try to put our sweep signal onto TP1 through the 5 picofarad capacitor, which is not too easy in and of itself. And we're going to try to sweep 10.7 megahertz in there onto a non-station and see if we can get on TP3 and get some things adjusted. And L3 is it, and I can tell you right now that it is adjusted, because if you look at the meter down here, this center tuning, you can pretty much tell, you can adjust that L3 and when you bring that in the center, the discriminator is pretty much aligned on this one. I know that's not the exact way you do it. You're supposed to use this little test point right here. You can see on the right. But I never seem to be able to get a good S-curve. So we'll play around with it a little bit, but I'm really not going to try to change it too much, especially with the fact that it's really hard to get a good S-curve on this. So let's set some things up and I'll be back. Okay, as you can see here, let me try to zoom in on the camera, or on the, come on. Try to zoom in on this thing. Let me get some better lighting here. There. So if you look at this, there's the mess I get for my S-curve. As you can see, what should be the marker is just a huge mess. With the demodulator probe, it's terrible. With a straight probe, right there's what I get. If you look at the meter, it is pretty well centered right now, and that was adjusting that L8. And I will tell you, when I bring this off center, I bring what kind of looks like my marker off center as well. So it's centered, but I just never could get a good S-curve. I don't know what I'm doing wrong. I've tried, you know, setting it on DC, AC coupling, all kinds of different things. I am just not a good one for the S-curve. I'll be the first to admit it. So that's where we are right now. We'll move on to the next thing and get set up for our next adjustment. Okay, our next adjustment's pretty simple. We're set up to our dummy test equipment here, dummy antenna, and we're coming out of the record out jack, as they ask for in the alignment thing here, REC record jack, and bringing that into the scope. As you can see, there's my waveform, and they want you to put it on to 90 megahertz, which I have my test generator set 90 megahertz, FM modulation 400, and you can hear it. And I'm just going to kind of bring it down till I start getting a little bit of static. Alright, and then I am going to go ahead and adjust for deflection, maximum deflection. LA 1 through 4. Okay, and what I found is pretty much LA 4, which is right here. That's the main one for your 90 megahertz, and you can see I'm off a little bit right here. I want to actually have this be right here on the 90 megahertz mark. I think these little hash marks represent the actual numbers. So we're going to put that right there, and we're going to adjust this until we get it come in. So I'll turn this up. You should hear it come in here shortly. Wrong way. And if you look, pretty accurate right there. Okay, we're right on. Okay. And you can see our discriminator is right at the center, meaning that our tuning is right at the center, which means our discriminator should be set properly. Now we have to do the same thing. We're going to move up. Everything's going to stay the same, but we're going to move to 105 megahertz. And same thing, we're going to adjust CTA1, which is that one right there. Alright, so go down to 105, which is exactly between 104 and 106. Frequency. See if I can get this in the shot. Sorry, I can't. 105 megahertz. So there we are. And you can hear that one's close. It's not dead on, but it's close. So we're going to get our adjustment stick here. See if we can turn this just a little bit. Sorry, I'm doing everything with one hand. And there we are. Perfect. Okay. So when we left off, we had to kind of get some of these adjustments lined up here, and what I ended up doing was I went back to my schematics and I printed out, I enlarged each section of the main schematic and printed it on separate pages so I could see the test points really well, and I went through all the alignments piece by piece. I used a combination of the SG165, alright, and I did use my old reliable here for the sweep, the WR50B RCA. It does a great job if you're just looking for a 10 megahertz sweep signal. and then of course use the old scope. Now, right now, I'm looking at test point 2, which is in the IF stage here. And as you can see, we're here. Got everything lined up. Went through all of these, peeked them out, using the scope. And last but not least, I got the discriminator working perfectly. Got my signal strength perfectly. The stereo beacon is working perfectly. And it was just a matter of going through the coils here and the trimmer capacitors on the tuning cap and going through all of the IF cans here. So we're now done with the FM section, and I'm pretty pleased with how it's working. And now we are going to get ready to go to the AM alignment. And once we do that, I think this thing will be ready to button up. And then one last thing I'll probably do is I want to recreate some nice wooden side panels. The original KR7400 came with like walnut side panels. This one didn't have them, they were missing, and so I'm going to go down to the wood shop and make a couple of nice ones out of some nice hardwood and paint up the top cover and make this real pretty and put it back into use. Okay, so next we're going to get set up for the AM. Okay, the next thing here is we are connected to TP7 right here, which is right on the base of this transistor right here with our 455 kilocycles. And we are going to our TP8, which is the output of the detector diode right there. And we're supposed to set for maximum deflection. So let's get in here, and it's L7 through L9. So 7, 8, and 9. So let's take a look at this. We're on number 7. Ooh, that was out. Wow. Alright, so let's shrink that a little bit. Right there's about it right there. Touchy. Okay. Let's go to a different tool. So we can... I hate these plastic tools. They're really hard. Oh boy. Let's try a different one. Very touchy. There we go. Okay. That's L7. L8, which is right here. This one right down here. Alright. Oh boy. Down some more. Right there. L8. And L9, which looks to be right down here. Let's see what it does. Let's stretch that out so we can see it a little bit better. Sure how sharp we want that to be, and I kind of think this is a one of those things where you gotta kind of balance it out. Okay, I think that's good. Okay, now they want us to put a modulated 1 kilohertz tone, 1000 kilohertz. So they want us to go to 1 megahertz, tune it into 1 megahertz. We want to go into the antenna jack, and we want 400 cycles, 30% modulation. So what I think we're going to do here is we're going to switch to a little more accurate signal generator. We're going to go up to the HP. Let me get set up for that, and we'll go from there. Okay, so we're set up at 1 megahertz, 30% modulation. I'm at negative 90 dBm. Just a nice, still getting static, but a low signal. And I'm going right into the antenna jack for the AM antenna. And they want us to look at the tape recorder out jack, which is what we're looking at, and you can see it's not a perfect sine wave because of course you're looking at all the static with it. We would expect that. And once again, they're going to have us do the same thing and basically readjust the same adjustments again. And what they're looking for now is, I think the first one was to get us in the ballpark, and this next one now is to make us get the best reception. So we'll see where we're at. So let's go back and do these 3 adjustments all over again, 7, 8, and 9. And you can see that one was perfectly peaked. I have a feeling we're not going to really need to touch these. They're all right where they need to be. That one was a little bit. We got a little bit more out of that one. So it was a teeny little bit of a turn more. Okay. So, done with that step. Now we're looking at the RF. We're going to go to 600 kilohertz. We're going to tune in to 600 kilohertz. And we're going to do LB6 and 10 and the ferrite antenna. So that is our next thing we're going to look at. So 600 kilohertz. Let's see here. Frequency 600 kilohertz. And I'm going to keep everything else the same. And we're going to tune down to 600. And of course this thing's not tracking perfectly yet, but okay. And we're looking at the same output, and we're looking at LB6 and LB10. So that's these two right here, this one and this one. So we'll get our RF stages tuned in. Ooh, there you go, got a little bit out of that one. And number 10. That one's a little more touchy. Okay, very good. Very, very good. Alright, next we're going to go to 1400. And we're going to look at CT 6 through 8. CTA 6 through 8, which is going to be, if I'm not mistaken, yep, 6 through 8. This is going to be on the tuner module itself, tuning capacitor module. So let's get over to 1400 kilohertz. And I'm going to tune that one in to 1400 kilohertz. Okay, and I'm thinking, no, we didn't do the ferrite antenna. We have to do that yet as well. And again, we'll adjust that. I'll do that last. Come back and pick that up. Okay. So 6 through 8. So that's just these three up here, 6, 7, and 8. So number 6. And of course that one's not making much difference. Seven. Yeah, that one peeking out. That was off by a little bit. And number 8. And that one I think is our dial accuracy. So I want to bring that right on to 1400 here and see if we just can't do that. Peek this out again. Whoop. Okay, and last but not least, we are going to do the S meter, and we're going to kick this up a little bit. Amplitude. Alright, we're going to go to -60. And I'm going to verify that our meter's at 4.5, and it's a little bit off, but it's pretty close. Confirm meter deflection at 4.5. That's awful close to 4.5. A little bit over, a little bit under, I mean. But all in all, not bad. Okay. Now, last of all, I like to take this off of here. I'll go to a loop antenna and or a loop coil loop here, which I have just a couple turns of wire. As you can see, I'm going to couple this up. I'm going to go back to my 600 kilohertz. So let me do this off camera so I get switched over, and I'll be right back. Okay, so here we are, got AM done. Again, I'm in a basement, on a hill, at the bottom of the hill, in a bad area, so I don't get the best AM reception. And we're in the middle of the day here.
To create memorable events and important meetings, the McKinley Grand Hotel in downtown Canton provides you.
So then just close the northbound side of Interstate 95.
Not too bad. I would say we're ready. So I guess next thing is to put everything back together and make some nice sides for it and test it out. Okay, and there it is, the completed project. I made up a couple of panels. I had some oak, so I guess they're out of oak. turned out pretty good. So there you go. Doesn't work too bad. Sounds really good. Can't wait to get it hooked up to a big set of really nice big speakers. So we'll try it out and call this project a wrap.